a quadratic inequality when there's only one variable. So hopefully this makes sense to you. So we are now presented with a quadratic inequality in just one variable. As you look at the inequality here, you'll notice that there's no longer a y and an x. It's just x. So before we do this, I want to review how to solve an inequality using just a linear inequality like the one you see here. 3x plus 2 is less than or equal to 8. Now, if it was an equation, there would be one specific value that would solve this equation for x. Probably be 2, because 3 times 2 is 6, plus 2 is 8. That'd be the solution to the equation. But I'm looking for solutions, x values that give me something that's less than or equal to 8. So while 2 would be a great answer, so would 1 or 0 or -1 or anything else. To show you how I would solve that equation, we learned how to do this back in Algebra 1 most likely. I would subtract 2 from both sides. So I solve it the same way I do an equation. It just happens to be an inequality symbol. So 3x is less than or equal to 6. I go ahead and divide by 3, and I end up with x values that are less than or equal to 2. And then usually when we had our answers to inequalities like this, we would often graph our solutions. So let's say that this is, we'll put 2 right here on a number line, and this is 1, and this is 0, etc. We would put a solid dot because this is or equal to at 2, and less than would mean to the left on a number line. So there's all of the values that are solutions to this particular inequality. So the same idea is going to apply here, even though I've got a square term. Now I have a quadratic inequality. It's still in one variable. Our answer is going to be an inequality, a set of x values that work for this particular inequality. So what we do is first we set it equal to 0, like we did when we were solving an equation in the last lesson. I'll add 3 to both sides. And we'll have 4x squared plus 11x plus 6. Now, this quadratic expression, we want to know, when is this quadratic expression greater than or equal to 0 now? So what I do is I'm going to figure out the equal to part first. So step 1 as we do this is to find the critical points. The critical points are going to be the values for x that make it equal 0. There's a number of different ways you could do that. One of them would be factoring or the quadratic formula or the British method. I'm going to use the British method for this one just because I believe it's going to work fairly quickly. 4x squared times 6 is 24x squared. Split that into factors that add up to 11. We're talking about 8x and 3x. Bring down the outside terms, which are 4x and 6, or 4x squared, excuse me. And then the next step in the British method would be to group the terms. So group the first pair, group the second pair. Out of the first pair, the greatest common factor is 4x, which will leave me with x plus 2. And in my second factor, I'm going to factor out a 3, so plus 3, which also leaves me with x plus 2. Common binomial factor of x plus 2 is the next thing that gets factored out. So the factors of this expression are x plus 2 and 4x plus 3. Now remember, we were wanting to know what, not just what the factors are, but what makes these things greater than or equal to 0. So what I do is I pick out the critical points. What are the values that make it equal 0? Well, -2 would make it equal 0, and so would -3/4. If I plug that in, that makes this equal 0. So those are what I would call the critical points. Now what I'm going to do is I'm going to test some values on either side of the critical points. And I think a good way to do this is to just make a quick number line of sorts. So I'll just get a quick line here. We'll put a couple of spots on. So there's 0 and -1, -2. Oops, go back here. We'll struggle here. It's okay. So put a couple of spots on a number line. Now what I'm going to do is I'm going to pick some numbers on either side of these. So if I were to label these as being at a couple different spots, we'll call this 0, and here's -1, and here's -2. -3/4 would be right about here. Now this is because this is an or equal to problem. I'm going to go ahead and put a solid circle right here at -3/4. We'll draw the arrow and say that's what that is. I'll put another solid circle at -2 right here. So now as I test points, these are what I would call my critical points, -2 and -3/4. This is where my quadratic expression is equal to 0. I want to know when is it greater than 0. So to figure that out, what I'll do is I need to plug in points that are to the right of negative 3/4, to the left of negative 2, and in between those two, because I want to know what do those x values do in my inequality. Now I can plug them into my original inequality that's way up here, or I can plug them into the factored version, which may or may not be easier. Let's find out. So I'll start by plugging in a value to the left of negative 2, such as negative 3. So what I do then is I decide, what if I plug in negative 3? Okay, so imagine negative 3 goes in here. Imagine negative 3 goes in here. We're going to have negative 3 plus 2 is negative 1. And then we're going to have negative 12 plus 3 is going to be negative 9. And when I multiply those two things together, negative 1 times negative 9, I get a positive number, positive 9. And is positive 9 greater than 0? Yes, it is. So this portion will work. Anything to the left of negative 2 is going to be good. Now, what about in between? Well, negative 1 is in between, so let's plug in negative 1 now. So if I plug in negative 1 for x, I end up with negative 1 plus 2 is going to be positive 1. And negative 4 plus 3 is going to be negative 1. Positive 1 times negative 1 is negative 1, and negative 1 is not greater than 0, is it? So this part is not going to work. Now, I'm going to bet that the right side of this is also going to work, but just to be sure, I'll plug in a number like 0. So if I plug in 0, let's say, 0 plus 2 is 2, 0 times 4 is 0, plus 3 is 3, and 2 times 3 is 6, which is greater than 0. All of these points are also going to work. So I've got two different sections to my graph. So the way that I write this then is my solution is x values that are less than or equal to negative 2, or x values that are greater than, to the right of, or equal to, forget about that, or equal to negative 3/4. And there would be the answer to my quadratic inequality. It's another inequality, but again, we're talking about a set of points that work in the original inequality when I plug it in. Another way that you can do this is, rather than doing the factoring thing here and coming up with the critical points, you could use your calculator to find those critical points instead. For example, if I were to graph the original inequality that I had, go back up here, the one where it's set equal to 0 is usually going to be the best bet. So I'll graph that. 4x squared plus 11x plus 6. And then I graph that equation. What I'm looking for is I'm going to use my graph to decide where are the critical points. Where is it equal to 0? Now I'm going to go ahead and calculate the zeros of this function, which is something that your calculator is pretty good at. Calculate the 0. Desmos is even better at this. If I want to calculate the 0, I would set up a left bound, hit enter, a right bound. This is me telling my calculator where to look. Right bound, and then enter in between somewhere, it guesses, and it comes up with negative 0.75. Well, that's negative 3/4, the number we had before. Now, again, you could work with this. You could use your calculator to find the zeros, okay, and then help you. The other thing you use your calculator for in the graph is to decide where is this greater than 0. Well, it's equal to 0 at the two intercepts, which is, easy to find maybe on Desmos or on your graphing calculator. So I know that this is at negative 2. I already found that that was at negative 3/4. And then I can use my graph to decide where is this function greater than 0. Well, it's going to be greater than 0 wherever the graph is above the x-axis. Here's all these positive outputs. So anything from here to the left is good, and anything from here to the right is going to be good, because those are the values for x that give us positive outputs that satisfy this inequality. So there you have it. Hopefully that made some sense to you, and you can figure out solving quadratic inequalities in one variable.